In this video, I'm going to show you how to calculate normal probabilities using tables. We're going to work through 4 problems, and then in the next video, we're going to work through the same 4 problems with a calculator. So let's begin. So this one is asking for the probability that z is less than 0.23. Now, a good thing to do in all normal distribution questions is draw a sketch. I'd say 90% of the errors that people ever make when actually calculating a normal probability problem is by not sketching it out. So I'll sketch out my normal distribution, put in the 0, and then where is 0.23? Well, that's 0.23 standard deviations above the mean, so it's here. And what are we looking for? We're looking for the probability that z is less than that. So we're looking for this area here. So we know the answer is going to be a little bit more than a half. So here's how we do this using tables. We're looking to create 0.23 from our table. So here's the table that you'll be given. And 0.23, where do we find that? Well, our first digit is 0, so 0.2. So you get your first 2 digits in the left-hand column. We find 0.2. Now it's 0.23, so we find the next digit here, 0.23. So 0.2 and the 3, and they meet here. So there's our answer, it's 0.5910. So 0.5910, and remember the notation here, when you look something up in a table, is phi of 0.223. That means the probability that z is less than 0.23. Okay, let's have a look at a slightly more fiddly one. So this one's fiddly because there are more digits here. So once again, so as not to be tripped up, we'll draw our quick sketch. We want the probability that z is less than 1.4 something. So put in your 0. That's going to be over here somewhere, 1.417. And we're looking for the probability that z is less than that point. So it's all of this area here. And we can see already the probability is going to be quite close to 1 because I've shaded most of my normal distribution. Now, the tricky bit is finding 1.417 in the tables. Here's how you do it. So it's going to start off okay. 1.41 begins with 1.4, so that's the row we're looking in. Now, it's 1.417, so the next digit is 1, so we get 1.41 is here. Now, for that last 7, you look for the 7 in this little add section up here, the 7 here and down to this row, and that little 10 there tells you how much you need to add to the number after the decimal point here. So it's going to be 0.9207, but we're going to be adding 10 to the 9,207 here. So I'll show you over on the other page what that looks like. So you had your 0.9207 here, and it told you add 10. You add 10 in this way. So what do we get? Well, 0.9217. So there's our answer, and written in phi notation, that would be phi of 1.417 is 0.9217. If it had just been phi of 1.41, the answer would be 0.9207. But when we looked in that 7 column, it said add 10, so you add 10 in this slightly odd way. If it said add 1, well, it would have just been adding 1 to this number, giving you 0.9208. So that's what our answer is there. All right, how about this one? Same z value, but now we're looking at the probability of being greater than that. Well, this is where you really need the sketches, because this just stops you making any silly errors. Here's the 0 point. Here's 1.417. Now we want the probability of being greater than that point. Now, we don't need to bother with tables here because we already know the probability of being less than that point. We just worked it out. It was 0.9217. So this bit here is 0.9217. Now we can use the fact that the area under the normal distribution has to equal 1 because it's probability. Something has to happen. And so our area here is just 1 minus 0.9217. So here's how you'd write all of this down. You would say the probability that z is greater than 1.417 is 1 minus the probability of being less than that. So that's 1 minus phi of 1.417. We worked that out, or in this case we already have worked it out. It's 0.9217, and then we calculate that. So 0.0783, and there's our answer. Let's do one more example. So the probability that z is less than negative 1.981. So again, we really do need the sketch here because this is just so easy to get wrong if you don't have a sketch. Your sketch does not need to be enormous or perfect, it just needs to be useful. So minus 1.981 is down here somewhere. Minus 1.981. And we're looking for the probability that z is less than that, so it's this. So what we do here is we do something clever. We use the symmetry of the normal distribution to say, well, what is that the same as? The probability that z is less than that point is the same as the probability that z is greater than positive 1.981. Because hypothetically, if we had the same point here but positive, then this region over here would be the same as this region down here. And we've just seen how to solve probabilities of z's being greater than something. We do 1 minus the probability of it being less than something. So this is going to be the same as 1 minus the probability of z being less than that, which is phi of 1.981. So in effect what we're doing is we're working out the area being less than this point, doing 1 minus that, that's giving us this region, which is the same as this region. So let's go ahead and work out what phi of 1.981 is. Right, 1.981. I start with 1.9. I then find column 8, and it's 981. So I add a 1, well, in this case it is just 1, to this. So it's going to be 0.9762. So here's how I record that down. 0.9761. There's the add 1, and my answer is 0.9762. That's the phi bit that I was looking for, 0.9762. I then get my answer, which is 0.0238. And there's my answer. So that's the process of solving standard normal distribution problems using the tables. In the next video, I'm going to work through exactly the same problems, but I'm going to use my calculator. And personally, I think that is easier. Feel free to do whatever one appeals to you most. See you in the next video.